Hi, my name's Adam. I'm here for the tour.
Welcome. Your tour begins now. Now listen. Now this is a little background info of John Dalton. In 1803, he developed the relationship between elements and atoms and established that compounds were combinations of elements. Also, he introduced the concept of atomic mass. Number 1. All matter is made of atoms. Atoms are indivisible and indestructible.
Why did he think that all matter was made of atoms?
Adam, are you going to ask a lot of questions? See, Mr. Dalton discovered that there was a relationship between elements and atoms, which introduced the concept of atomic mass. I was trying to explain it to you. Now listen and ask questions later.
Okay, I understand now, I guess.
Number 2. All atoms of a given element are identical in mass and properties. Number 3. Compounds are formed by a combination of 2 or more different kinds of atoms. Number 4. A chemical reaction is a rearrangement of atoms. Look at this picture.
Can I keep it?
Sorry, but no. This stuff is very valuable to scientific history. Now let's keep moving, kid. In April 1897, J.J. Thomson announced the discovery of the electron. Thomson reported that this tiny particle had a negative electric charge and a mass of about 1/2000th of that of the lightest atom. In 1904, the plum pudding model was proposed before the discovery of the atomic nucleus. In this model, the atom is composed of electrons surrounded by a soup of positive charge to balance the electron's negative charge, like plums surrounded by pudding. Rutherford observed from his Goldford experiment that although most of the alpha particles passed right through the target, many were deflected at very large angles. Some were even deflected backward, as if they had hit a stone wall. Most of the alpha particles went right through the full. He reasoned that the atom was mainly empty space and capable of repelling and scattering the projectiles fired at it. He called this the massive core of the nucleus atom. Here's a picture of Rutherford. Okay, now Niels Bohr. In 1913, he published a theory about the structure of an atom based on another theory of Rutherford's. He suggested outer orbits could hold more electrons than the inner ones, and that these outer orbits determine the atom's chemical properties. Bohr also described the way atoms emit radiation by suggesting that when an electron jumps from an outer orbit to an inner one, that emits light. Later, other physicists expanded his theory into quantum mechanics. This theory explains the structure and actions of complex atoms. Here's a picture of Bohr.
Did you rehearse this tour? Because you sure do know a whole lot of stuff about these people.
No, just really liked scientific history and found for the most interesting part, the electron cloud model. Electron cloud model. This represents a sort of history of where the electron has probably been and where it's likely to be good. Now, one person came up with it. J.J. Thomson, John Dalton, Ernest Rutherford, Niels Bohr, and Werner Heisenberg all led up to this, but didn't discover it. But they are all very smart people. Here's a picture of the electron cloud model.
Wow, it's so cool. How come no one came up with it?
Because, Adam, there wasn't enough evidence at that time to provide any of them with the information of the discovery.
I bet I could have discovered it if I was a scientist.
Yeah, I'm sure that Adam could do something like that. Ha ha. Okay, well, the tour's over. You can go home now.
Okay, bye, Steven. Hey, Steven.
Yes, and it's Professor Steven to you, and I thought you left. That tour I gave you earlier was not supposed to be any longer.
Could you explain this so-called atomic structure?
Can't you see that I am making a big break in a scientific discovery? You have asked too many questions already. I am tired of it.
Please, I have to know so I can pass my test. This is my GPA at risk. If you don't, please.
Alright, here's a picture of an atom.
Cool.
Now pay attention. Now the protons and neutrons are located here in the nucleus. Protons have positive charges and neutrons have a zero charge, but electrons are located outside the nucleus and they have a negative charge. These are all subatomic particles.
Wow, this is crazy how they all have different charges.
What grade are you in again?
Steven, can you tell me one more thing about the atomic structure?
What kid? What else could you possibly have to ask me about this or anything else?
Calm down, old man. I heard my teacher say something in class today about isotopes.
It's isotopes, not isotopes. Anyway, isotopes are atoms of an element that have different numbers of neutrons and different mass numbers. Now, anything else?
Tell me about the periodic table.
This is the last thing I'm explaining.
Okay, calm down, sir.
Let me get a periodic table out. Okay, now groups like these are the columns in a periodic table.
Whatever, old man.
This is the last time, you freak!
I was joking, Stevie Weevy.
For the last time, pay attention. I'm going to stab you. Now, a period is sometimes referred as families or rows in the periodic table. See? Look at this. Here are the alkali metals, alkaline earth metals, and metals, etc. Well, that is enough. No more questions. Goodbye!
Well, thanks for the tour, old man.
It was my pleasure. Now get out of here.